Over here we have a simple pendulum of length L, the string length is L, that is oscillating. We want to prove that T, the period of the full cycle, is equals to 2 pi multiplied by the square root of L, the length, divided by the G, the gravitational, the acceleration due to gravity. Okay, so the assumption here is that that's a simple pendulum, which means that the angle is considered to be extremely small. It's 3 to 4 degree, not more than that, which means that the sine theta can be rounded to theta, and that cosine theta could be considered to be equals to 1. Okay, so in order to solve this, to prove this, we need to consider an FBD. Okay, so that's the mass. We know that we have the weight, which is equals to mg. Okay, we have the tension. I'm gonna call the tension this time not T, because I don't want to confuse you between tension and period. So let's take the T tension as the letter R. Now these are our two forces. You remember that we need to find the X component of R, the force tension, and the Y component of the force of tension Ry. And remember that this angle is exactly equal to this angle theta. Okay, now we know that our system should be split between the X and the Y, all the forces acting on X and all the forces acting on Y. The motion is solidly happening on X, so the sum of the forces is equals to ma, while here the sum of the forces according to Newton's law is equals to 0. According to Newton's law is equals to 0. Starting with the X, we have how many forces? We just have Rx. Do we have anything else? No, Rx. So Rx is equals to ma. Let me put this here. Yeah, so Rx is equals to ma. Rx is, if we look at this triangle over here, right, that's theta, that's R, that's Rx, and that's Ry. So Rx is equals its opposite, so it's R sine theta is equals to ma. Sine theta is assumed to be equals to theta, so R theta is equals to ma. Now, you should know something important about the system is that, as we said, the angle is extremely small. The variation of the angle is very small. So it's something kind of like this, where this side over here represents the displacement x of the pendulum, so it's going back and forth, back and forth, back and forth. And this big L is the length of the pendulum, and that's the angle theta. Oops, okay, that's the angle theta. Yeah, so in order to find theta, we can divide what x over L. So R x divided by L is a. And this is a simple harmonic motion system. So what do we know about simple harmonic motion system? We know that the acceleration is proportional to x. So the acceleration is equals to omega squared x. If you don't know why, go and watch my other screencast. So R x divided by L is equals to m omega squared x. Now we can simplify by x, and we will get that R divided by L is equals to m omega squared. And that's a very important step, because we just found a relationship with omega that's equals to 2 pi divided by t. So we just got our t, which is this, out of our equation. Now, you can see that in this equation, what we don't have yet is R. So how can we find R? From topic 2, we know that we should look at the y component of the system. And on the y component of the system, we have two forces. We have R, y, and we have mg. Ry acting in the negative, Ry acting in the positive sense, so Ry, and mg acting in the negative sense, so minus mg is equals to 0. Okay, now Ry according to this triangle is equals to R cos theta. So it's R cos theta equals to mg, which leads us to R, and cos theta is equals to 1 according to this assumption. So R is equals to mg, and now we can replace this relationship over here and see what we will get in the end. So mg divided by L is I'm gonna replace it direct omega squared directly by this, so 2 pi over t, that's squared, since it's omega squared. I'm going to simplify by m. We get that t squared is equals to 2 pi squared multiplied by L divided by g, which leads us to t equals to 2 pi. If I square root this, it would be 2 pi and the square root L divided by g. Okay, and this is our relationship. All right, so using the equation that we just proved, we are going to investigate a simple pendulum in order to be able to determine the acceleration of free fall due to gravity g, which theoretically is 9.81. So we're gonna see, can we prove that acceleration due to gravity is equals to 9.81 using a simple pendulum. Okay, so these are the method. You should spot what the independent, state independent, dependent control. These are the equipments, and these are the results that we are going to record.